This is part 1 of a lecture for Monday, March 30th as we continue AE 514 online. I hope you're safe and staying healthy wherever you have landed during this pandemic. So this is feedback on homework number 5. I'll give you, just as usual, spot checks for answers and some information you need to complete the homework. This homework needs to be uploaded to Blackboard by 10:30 a.m. on Wednesday, April 1st, which is the due date for the homework on Blackboard. Check additional information on Blackboard for the instructions on uploading that as a PDF or as images. All right, so starting with problem number 1, your job is to find C-bar, the lift curve slope of the fin, and the location of the aerodynamic center, X and Z, of that fin. As it states in the homework, what you're going to do is assume that B over 2 is 5.5 feet. So you're reflecting the fin downward and assuming that it's bigger than it really is, and that's just for part 1 here. What you're going to calculate then using the root chord and the tip chord information, and this span is you'll calculate C-bar, and that should be 10.296. Next thing you do is use the big formula for AF, so this is from Roscom. You're using the area, which is double the actual fin, and the fin span of double the actual fin, so that includes its reflection, and so your area is going to be twice that. So the area you're going to use in this calculation is 101.2, and you're going to use those in the formula to calculate the half chord sweep angle and the aspect ratio. So double check those answers. Again, you're using, for this problem, double the fin area, double the fin span, just to calculate this. So once you've got those, they feed into the big formula, and you should get this number for your fin lift curve slope. Again, that's the big formula from Roscom, and the formulas for C-bar are from the Roscom handout way back when we did the wing early on. All right, so once you're there, then you go to Appendix C. This is the same formulas we used before for Y-bar and X-bar, except now you're calculating the Z location and the X location of the fin, and you should get these numbers, 2.2. You'll need the tangent of the quarter chord for the formula for X, and then here's what you should get for X of the fin, 6.975. So that's the end of problem 1. You're getting that information that we'll need later on in this problem. Problem 2, LF is the distance from the CG to the fin AC. So this is the moment arm that we use in our calculations for the fin. It's going to be 25 feet from the picture, and then you're going to add in the distance XF back from the apex, and then subtract off the CG location from the datum. So you should get this number here. Hopefully everybody's matching these numbers. If not, you've got enough information to go back and figure out what you've done wrong, and then you just stuff those numbers into the formula for the volume ratio. And some of the data you need for that is the wingspan and the wing area from an earlier homework. Go into the formula that is you're pointed to for CN beta fin, and you should get this number here. So you'll need LF for that, because that's going to give you CN beta. All right, problem number 3. CN delta R, the yawing moment coefficient due to rudder. I've pointed to this formula in your book. You can find that. You're going to need AR to feed into that. This is the lift curve slope effectiveness of the rudder. It's CL delta R. In your appendix, this is called CL delta, and you go to page 322 for this. You're going to calculate CL alpha. Actually, you need CL alpha for the fin, so you go back to problem number 1. You just calculated that on this homework, so you'll grab that. Then you go to this appendix, and you're going to use CL delta, which you're going to need up here. we're assuming it's theory, so don't use all the correction factors, and you should get something close to 3.6. And then feeding into the formula for AR, you should get this number here. And then the formula for CN delta R is minus 0.04321. Make sure that you copy page 324 with the point you picked to give you the number up here, because that will be part of the grade, is making sure you copied that figure. Alright, problem 4 is the derivation. You're going to calculate the side force due to the rudder. Here's the CG. Here's the AC of the fin. We just calculated that. That's this point right here. Not a great circle, but that's the way it goes. So then the side force is going to be generated sideways this way due to the rudder deflection. And so the rudder effectiveness times the rudder deflection gives you the coefficient side force, and then you multiply by Q bar and the area of the fin to get the side force. The moment, this is a rolling moment, is just the force times the moment arm. Make sure when you do this derivation you justify the sign based on where the force acts and where it is relative to the CG and which way is positive or negative. Divide by 1/2 rho v squared SB, and you will get the rolling moment coefficient, which then you'll differentiate with respect to rudder, and you'll get this number here when you plug numbers into that formula, where you're using this value that we just did in problem number 3. Make sure that you justify this sign here based on the vertical moment arm, because that's what gives you a rolling moment here. Alright, the last part is the spreadsheet. Let me rotate this from my document here so you can see it better. And these are your hand calculation values. On the line of 400, so that's in that speed. And what you did was you added this number here where you calculated the delta E due to the pull-up. Alright, so I realized I was missing this page, so I went down and scanned it in. Here we go. Problem number 5, before you need to do the spreadsheet, is you'll use the formula for CMQ given in the homework, and here's the data that you need from previous homework for that. From homework number 3, you'll get these VH, and you'll need LT of 20.8 and C bar of 15.2. You'll also need the determinant that we used in the previous homework, and the mass ratio you'll have to calculate using the formula. The weight coefficient is just CL trim. There's the number for that. And again, we're doing this at 400 feet per second. So you plug into the formula from the book for delta E for that pull up, and you'll get minus 0.1162 radians. Then you're going to add a column to the spreadsheet of homework number 4I, which is what we were looking at just previously. So here's the spreadsheet. Let's rotate this, and this is in degrees here. So you'll calculate that value, verify with your hand calculations, and then you'll do this plot here. The other plots we've already done. So this is a plot of the elevator change per velocity, and this slope gives you good feedback to the pilot. So that's homework number 5I. Hopefully this is helpful. The next part of this lecture will be covering using X-plane.